Okay, so today we're going to start with number 16. Consider the orbital diagram in Model 3. How many electrons are there in one atom of this element X? So electrons, we're just going to count the arrows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 electrons. Identify element 6 and provide a ground state electron configuration. Assume the atom is neutral. Okay, so this is 10 electrons. And if it's neutral, that means it has 10 protons. Protons is the same thing as our atomic number. So we're looking for neon. So this is neon. Okay, so go ahead and write down the element is going to be neon. Right there. Identify the element. It is neon, and we can do this because it's neutral. Is the arrangement of and the electron configuration. Okay, so 1s2. Oh, it wants the ground state. This is not the ground state. This is actually something different because notice how this one is up here. So we're going to do the ground state electron configuration. Oh, well, actually, no. When we're writing the electron configuration, you can't even. You will be able to tell. So we'll say 1s2, 2, level 2. I'm in the S block, S, the S room, add 2 in there. Now 2p, I've got, now if it was a ground state, this one would be down here where it was supposed to be like this. And so I'm going to say 2p6. That would be the ground state. Is the arrangement of electrons in the orbital diagram above, a diagram in Model 3, higher in total potential energy or lower in total potential energy than the ground state electron configuration? Okay, so as we go up, we get more potential energy. As we go up, we have more potential energy. And so we have more. Is the arrangement of electrons in Model 3 higher? So it is higher in potential energy because there is an electron in the third level, right? Because you've got level 1, level 2, level 3. In the ground state, electrons only fill up to the second level, level 2. Okay, all right, read this. An excited state electron configuration is any electron configuration for an atom that contains the correct total number of electrons but has a higher total electron potential energy than the ground state electron configuration. So the ground state, the highest electron goes into the second level. This is an excited state because we have this funky electron up here in the level 3. Now, I wouldn't expect you to know what level an electron would jump to, but if I showed you something like this, and then you would say, oh, I know that this is an excited state electron because that guy should be right here. But notice how it still has the same number of electrons, right? There's still 10 electrons here, but one is just not in the right spot. So we want to be thinking about how this relates to fireworks. And what happens is when this comes back down to here, because it gets excited and then it comes back to its ground state, something happens. It gives off color, and we're going to talk more about that. Right. So number 17 says, write an electron configuration for the element X that shows the atom in a different excited state than the one illustrated in Model 3. So we're just going to make up something here. So this is the excited state up here. And I'm just going to pretend like I'll just put the electron here instead of here. It doesn't matter. okay? And they just, what I just want you to know is that it's not the ground state. So, okay, so here we go. I've got 1s2, second floor, 2s2, 2p, 1, 2, 3, 4, 5. Normally there's 6 in there, right? And then I'm just gonna jump to 3p1 because I've got 1 in the 3p. Okay, so this is an excited state. What should really be happening is this one should be over here, but that electron has jumped up to a higher energy level. But again, notice how we still have 2, 3, 4, 5, 10 electrons total. So we haven't changed the element, it's still neutral and neon. Number 18. Each orbital diagram shown below describes an excited state describes an excited state of an atom of a different element. So they're all different elements. So this is an element, that's an element, that's a different element. Element A, B, and C. Use the orbital diagram to complete the table. Okay. So let's take a look at letter A. That's this one right here. Excited state electron configuration. So let's go ahead and write down what we see here. So on the first level in the S floor, we have 2 electrons. On the second level in the S floor, we only have 1. And then on the second level in the P, we have 3. And on the third level in the S, we have 1. Okay, so we know that this is not normal. This is an excited state because normally the S block would need to be filled up first before anything here, and these would need to be filled up before anything there. Okay, identify the element. Well, let's just count the electrons. 1, 2, 3, 4, 5, 6, 7. You know what? Let me grab anything in here. Boom. Work smarter, not harder, Miss Moore. Okay, so 7 electrons. Okay. My atomic number for this stuff is going to be, oh, I can't see, on the bottom. So we're going to call that one nitrogen. So this is nitrogen because it has 7 electrons here. Oh, I should probably write that right here. Okay. The ground state electron configuration. So this is what it should look like. It should be on the first floor in the S, there should be 2. On the second floor in the S, there should also be 2. That's 2, 4 electrons. Okay, so all I can do is add 3 more. And then on the second floor in the P block, 1, 2, 3. 3, 4, 5, 6, 7, okay. 2, 3, 4, 5, 6, 7. Okay, so we have the same number of electrons in both. We know that there's 7 electrons because we've got 7 arrows. But this is how it should look. This one's skipping around. This is the excited state. This is the ground state. Okay, let's take a look at this one. Okay, let's go ahead and write what we see here. So in the first floor, in the S, we have 2. Second floor, S, we have 2. Second floor, P, we've got 6. Third floor, S, we've got 1. Third floor, P, we've got 1. All right. So let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 electrons. In a neutral atom, 12 electrons is going to be magnesium because that's the atomic number and it's got the same number of protons and neutrons. Protons and electrons. Okay, so magnesium, Mg. And the ground state, what should it look like? Well, okay, so let's start from the bottom, move up. It should look like this. So 1s2, 2s2, 2p6, and it should have 3s, and there should be 2 in this one. That's the ground state. It's just excited. Energy has been added somehow, and this has hopped up here. Okay, let's look at our last one here. So let's draw what we see. So 1s2, in my 2s I have 2, in my 2p I have 1, 2, 3, dang. And then in my 3p I have 1, 2, 3, 4, 6. Right, so that's 2, 4, 6, 7, 8, 9, 10, 11, 12, 13. 13 electrons. That's aluminum. Aluminum, and this is a 13. Okay, so what should this look like? It should look like this. 1s2, 2s2, 2p, oh wait, so I've got 2, 4, so I need 9 more. So 6, 2p6, 3s, so 2, 4, that's 10. I need 13, so I'm going to put 2 in there, because I can only put 2 in here. And then my 3p, I'm gonna put 1. Let me double check. 2, 4, 10, 11, 12, 13. Okay. 2, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, yeah, so my electrons are the same in both, but this is the ground state. This is how it should look, and then when you add energy somehow, it jumps up to here. Okay, last part. It says complete the table for each of the excited state electron configurations given. Okay, so this is the excited state over here. So I've got 2, it wants to know the element name. First we need to figure out how many electrons are there. So 2, 3, 4, 5. So there's 5 electrons, which means if it's neutral, which it is, it's going to be 5 electrons boron. Ground state electron configuration. So what should it look like? So it should be like this. 1s2, 2s2, 2p1, so 2, 4, 5. Okay, orbital diagram for ground state. Okay, so it should look like this. So we'll call this the 1s, 1, 2. This is the 2s, 3, 4. Okay, we'll call it 5. I should like this. 1, 2, 3, like that. Okay. All right, now let's take a look at this one. So what element is it? Let's count the electrons. 2, 4, 6, 8, 9. So there's 9 electrons. 9 electrons over here gets me fluorine. Okay, so what should it look like? It should look like this. 1s2, 2s2, 2p, let's see, so that's 4, so we need 5 here to make 9. Okay, what does this look like? 1s, 2s, 2p. So let's put 2 in here. We'll put 2 in there, and we'll put 1, 2, 3, 4, 5. Just like that. Okay, and that's how you do it.